Hello and welcome to everybody on Cloud Fitness. So in this video today we are going to discuss Apache Spark Core Concepts 2. We will be talking about RDDs, we will be talking about data frames, we will be talking about transformations and actions as well. Now this will be both theoretical as well as a hands-on session. So first we will go through the basics of theory and then we will move on to the hands-on session. But do remember to like, share and subscribe to my channel. So coming on to the resilient distributed data sets, the RDDs. So what exactly an RDD is? So in my previous video I have been talking that a DAG is created using RDDs, right? What is an RDD? So whenever RDD is basically a data structure in Spark, right? The very first thing. Right, so whatever you do in Spark that gets converted it in form of RDDs only. That is called resilient distributed data set. Right, so whenever an object is created, whenever you try to read the data, that reading of the data is also done through an RDD. Writing of the data is also done through an RDD only. That was in fact RDD is basically the basic API in Spark. So it is a very basic, or it is the lowest level API which is available in Spark. After resilient distributed data set, we Spark came up with the data frame API, which is called a data frame, which is even little more tabular like format. Resilient distributed data sets, RDDs, are not a tabular format. So both these two, the RDDs and data frames, are the Apache Spark data structures. So whatever you create in Spark, it gets converted in form of RDDs only. So even if you write code in data frames, it will by default internally by Spark, it will be created in form of RDDs, and that is when your DAG and everything gets created. Right, so when you talk about RDDs, let's say you try to read a file. Right, now you read that file in form of an RDD, or you read that file in form of a data frame itself. Now when you try to do any manipulation over it, now when you try to do a filter operation on that RDD, you will do that filter operation on that RDD. Right, because that RDD has already loaded the data from your file. Now when you do a filter operation, you create a new RDD out of it. So one RDD is created, you do a filter operation, you do any kind of transformation on top of it, another RDD gets created. So RDD is resilient and it is immutable as well. So you cannot change the previous RDD. You can create a new RDD from the existing RDD. So if I have RDD which I have created by reading a file, I cannot change it. I just can create a new RDD out of it. And when I say a new RDD out of it, so automatically what will happen, the DAG scheduler, if you remember, so RDD1 will point to the RDD2 with the operation with what I have done. So that creates a DAG, that creates a directed acyclic graph. That does not have a cycle, right? It has the RDD, right, as the vertices and edges as the transformation. Right, so that happens in the background, but now when we work on Spark, we basically write it in form of the data frames. Right, so data frame API is also available with your Python, R and the Scala language, but your RDD is available with Python and Scala language along with Java, not with R API, not with R language. So we will actually see how does this RDDs and data frames looks like. We have been talking it in terms in theoretical terms, which doesn't make much sense, right? So now if you see, don't think much about the code right now, we will discuss about it. Right, let me execute this part. So what my first command is doing, I already told that for execution you can execute it from this run option, or you can just do control, you can do shift and enter. That will also run your cell. So display, I am trying to read what is present here. Right, I am trying to read a sample document. I am trying to read a sample document at a particular location. So this is what I am trying to do right now. Okay, now in the command 3, basically, if you see, it is written in Scala. So this is the syntax, basically val text file. So this is nothing but your data frame. Right, this is your data frame that you create. So you create it using val text file. So this text file is nothing but your data frame. right? And then you do something like spark.read.text file. Don't worry about these APIs, we will talk about it. So you are just, and you provide the path for the file and you just try to read it. Now once you read it, right, what you have done, you have created an RDD out of it. This is an RDD, like you are writing it in data frame API, but by default internally it is created as RDD. So this is a data frame that you have created. Now using this data frame, you kind of you can do any kind of operation on top of it. You might want to count the data, count the number of rows which are present using this dot count operation. So this will give you a count of data, right? So this is how basically you this is how visually our data frame might look like. It look like this. That's all. This is what I wanted to show you here, correct? And now, and also let me do one thing. So if I open this part, Spark job, so I already told in my previous video that stages are created, tasks are created. So if I click on this view option over here, I'm going to show you a really interesting thing. So this is a job, right, that we have done a count, right? Now if you see, this is the DAG visualization. So this is where you can visualize your DAG. So this is how DAG looks like. So even if you see, if I hover on it, shows a graph of stages executed for this job, each of which contains multiple RDD operations, right? So if you see, this is how a DAG is created from your job. So right now I have done I have used just an inbuilt function of count, right? So this is how your DAG is created, and there are a lot of things which we can we can get to know through this. How many executors, how many drivers were added and removed, we will talk about this later, but just wanted to show you that this is how you can actually visualize the DAG also, which we talked about in our last video. Now coming on to the RDDs and data frames that we talked about, right? So now when we talk about RDDs and data frame, how do we create an RDD? How do we create a data frame, right? That is again a question. Now when you talk about an RDD and data frame, so if you see, name does not matter. So right now I am in a Python notebook, right? Remember that this is Python, right? So there is something called as Spark context, right? So using Spark context, we create an RDD. So usually in our day-to-day practice, or in your company or in your workload, you are not going to create RDDs. You will only create data frames, but it is good to know about the RDDs also. So this is how you create RDD. You import a Spark context, right? You need a Spark context, and what you essentially do is, using your Spark context, you can actually create an RDD. So iris1 is equal to sc.text file store tables iris.csv. So this is a location where your text file is present, and using this Spark context you are creating a RDD, and then you are just doing a collect action. You are adding a collect action over here. So the moment you basically, here I am just trying to display the contents of my file. If I say it in one line, so I am reading a file and then I'm I'm trying to display the contents, and using a Spark context I have created an RDD. So the moment I do this collect and I try to print, so this is how it looks like. So using RDD, the output looks like this. However, if you do the same thing using a data frame, the output looks even much better. So if you see, let me in fact show you, I will have data frame as well. So this is how the data frame output looks like. Let me show you. So here you go. Let me go a little up. So importing data as a data frame. So how do you import the data as data frame? So nothing, using Spark API. That's all you need to do, right? So here if you see, this df1 is a data frame, right? Using this data frame itself, spark.read.csv, using only this spark.read API and mentioning the path over here, and just having, this is a syntactical thing, header equal to true. Just by doing this, right, you can create a RDD, right? Spark.read.csv. But in the previous, when we talked about the RDDs here, there we were not using spark.read.csv, right? There we were using spark context sc dot, right? We were using spark context over there. But usually in your day-to-day workloads, you will be only using data frames. And also when you look at the output, right, when you try to look at the output, usually you should write display, not show over here, like okay, I'll talk about that later. So essentially what I mean is, if you do this spark.read.csv and you create a data frame out of it, data frame name can be anything, and then you try to do a select operation or you do anything on that, basically you will see the data looks like this. It comes more in a tabular and a readable format. So that is why people mostly go for data frame, and it is easier to do operations on data frames than on RDDs. And I have also created video on RDDs and data frame coding in detail. I will leave the link in description. You can check that video out after this one, because that is also a really important video that will help you to distinguish between RDDs and data frame. You can create a RDD from a data frame and you can create a data frame from an RDD, right? But for normal coding purpose, we will only use data frames. So for example, if you see, this is a data frame, right? Spark.read.csv path, this is a data frame 1, this is a data frame 2, and then you can do a join on these two data frames. So this is usually how we kind of code, or we kind of do work in Spark world. So now let me go back to the PPT over here. If I talk about transformation and action, so now what is transformation and action? If you see, when we were trying to do a reading, right, we were first reading a file, right? We were trying to do a read operation on a file. After that, what we usually do, we kind of do a transformation on, or we try to apply some business logic on our data set, right? We try to provide let's say we want to filter non-null values in from our data. So that is a kind of a transformation that has to be applied, right? And in terms of Spark, there are two segregations. One is transformation and one is action. Transformation is the business logic. So if you want to do any kind of group by, you want to do a reduce by key, you want to do a join, so all those are transformation, right, which modify your data frame. So you create a data frame. I read a file, I have created a data frame, right? Now that data frame has some value, right? Now if I try to do any kind of transformation over it, it will change its value. So if I want to do a filter operation, now the new data frame which I create, right, the new data frame which I create, that will have another value that will not have the value of the previous data frame, right, because I have applied some logic over it. So that business logic is called your transformation. So you need to understand it thoroughly, that transformation is a business logic, right? It is now ETL, right, extract, transform and load. That is the word of data engineering, right? So this transformation is nothing but any business logic, filter, aggregate, group by, reduce by, union, join. So these are all transformations. And then here come the second thing, which is action. Now what is this action? So when you have written all these transformation, but then you want to execute the transformations, that is when you call an action. So action will basically put your code together, and it will go to Spark and say that these are the transformation I want to do over my code. That is what is called an action, right? So action is basically liable to perform all the transformation that lead to that particular action, right? So in fact, let me show you through the code itself. So if you see here, right, first of all, what I am trying to do, I am trying to read a file here, right? Spark.read.text file. That I am saying that, hey, I have my file over here, just read it. Let me zoom it as well. So I am telling my Spark that please read this file. And now this is a Scala notebook. Remember that it is a Scala syntax. So in Python you don't need this val. You can simply write text file, but in Scala basically you need this val. So this is a transformation because it is changing the value of this text file, right? I am reading my text file, I have this val, right? Let me just execute it first, then you'll understand it better. Now here also, if you see, if I do a simple display on this text file, basically this is a data frame, and now I am showing my data frame. I am saying show me my data frame, right? Now you see the difference between both these two commands. There is a very subtle difference. When I ran this command and I open this, right, there is nothing has been done over here. Spark has created no job out of it. There is no job, right? It is just a transformation. But when I did a display, it has created a Spark job. So if you see the output, right, in the output it has just defined text file above, but in down it has created a Spark job out of it. The Spark job has stages, the Spark job has tasks, right? If I open it, you will see there is a DAG created and all, right? So now why did this happen? Because this display is an action. In my previous video, I explained that whenever you call an action, then only the whole architecture of Spark will work. Now when you create a transformation, nothing is going to happen. Only your data frame will get created. If you want to do any filter operation, new data frame will get created, but the job will not be triggered. Actual execution will not happen. But using this display, what will happen using this display? What this display is doing, this is saying that, hey, show me this value which I have created. So above, this command did not execute, it's just created a data frame. But here I am trying to show my data frame. I am saying just execute whatever has led to the creation of this data frame. So that is why this is an action, and it has given us this value and it has created jobs out of it. So similarly, there are a lot of actions. So this count operation, so count is also an action, right? If I run this, you will see it will start creating a Spark job, right? It will start creating a job, and it has given the output as 65. So what it is doing, it is saying that in this text file, this is basically my data frame. In this data frame, go do the count, do some operation, right? Give me the count of it. So that is an action. Similarly, the first, right? This first is basically, this will give you the first line from the text file. So text file is a data frame. Now from that data frame, get me the first value, right? So that is what first is used for. So it will go ahead and give you this value. So it is giving you some output, right? That is why it is called as an action. So similarly, let's say you want to do a filter, right? And you can see this text file, right? Using this data frame, I am creating another data frame. So now I already told you that one data frame, right, once it is created, you cannot change it. You cannot change text file, but you can create a new data frame out of it. Now to create a new data frame out of it, you will say that, hey, this is my text file. This is already a data frame created. Now using this data frame, create another data frame, right? Using this data frame, do a filter operation, and using this filter operation, create another data frame. So this is a transformation that is happening because it is creating a new data frame out of it, right? It is creating a new data frame, but it is not doing any work. It is just defining that, hey, lines with Spark is a new data frame which will be created from text file using a filter operation, using a filter transformation, right? So, and you can see that there is no job executed, right? But when the moment I do a count operation, lines with Spark, the moment I do perform a count operation, what will happen is it will create a job, it will trigger a job, right? And if I go and click on now, if I click on stages, now you will see again a DAG is created. Now in this DAG, see, a DAG is created. So this is how things work here. Now let's say there are multiple operations that you need to understand, that you need to do, that you need to know. Let me go back to PPT. Now if you see actions, what are the different actions that you can perform? Actions basically means getting the output, right? If you do any kind of collect operation, that is an action. If you do first, that is an action. If you do take, it is an action. Take 5. So if you do a take operation, what will happen is it will take few rows, you know. So if you do any kind of count operation, if you do min, max, mean, save as text file, collect as map, top, for each, take, first, fold, aggregate, collect, reduce, these are all actions. they are going to perform some work. So first is the transformation, and then an action basically calls your transformations that you have already defined. And these are the some example of the transformation: map, filter, flap map, group by, your count, your zip, your coalesce, your repartition, your sample, sort by, group by. So these are not performing any work as such, but they are leading to the creation of a new RDD or the creation of new data frame. So those are called your transformation. Now even in this transformation, there are two types of transformations, right? First one is a narrow transformation, and the second one is wide transformation. So what does this narrow transformation mean? So if you see this particular diagram of the narrow transformation, what is happening is each input partition is only contributing to the creation of one output partition. For example, map, right? When you do a map, what happens is X will lead, so whenever you create a map, an operation happens on each and every element, right? Each and every element, and it leads to the same element out as an output. But in case of wide transformation, what happens is, for example, you are doing a group by key, right? So what happens is you have given multiple partitions, but the output is not 1 to 1. Output might be 1 to n. Group by key, the moment you group by key, the number of partition gets reduced, right? So what is happening here, that is called a wide transformation. So any such transformation which is a wide transformation, that will involve shuffle. For that you might need to take the data from different partitions, right? Because it is doing a group by kind of operation, or reduced by kind of transformation. So that is called a narrow and a wide transformation concept. Right now what you see on the screen is map, partition, group by key, reduce by key, join, distinct, intersect, flat map, filter, union. Now you tell me, for example, I'll just use union operation. Okay, now in this union operation will be a narrow transformation. Why? Because it is a one-on-one operation, right? So each row will give one row is mapped to the one row of the output, right? So that is a union. Now union is a narrow transformation. Similarly, filter is also a narrow transformation. Now I would want all of you to do some research and try out and check what are these each and every transformations. They are narrow transformation or they are wide transformation. Just hold on, just pause this video. If you know already, just write it in the comment section whether map is a narrow transformation or a wide transformation. Group by key is a narrow transformation or a wide transformation. And if not, just do some research, create your own notebooks, start writing something, start writing some code, and start googling, start writing some code, and you will actually eventually understand which transformation is a narrow transformation and which transformation is a wide transformation, right? So thank you so much for being till here, and do remember to like, share and subscribe to my channel. Thank you so much.